Let me just get started with a quick introduction. My name is Hector Rios, and I'm the Associate CIO of Networking and Infrastructure. A little bit about me. I was born and raised in Mexico, moved to Louisiana at around uh, 20 years of age, lived there for many years, lived in Texas in a couple of cities there, and I have worked in the IT industry for over 20 years. Mainly in the higher ed space in large public universities. And I joined UK 3 years ago. This month, 3 years ago. Time flies by. So I've been here ever since and enjoying every bit of it. I'm a dad. I'm a husband. I have two kids, a boy and a girl. Uh, have a little feisty chihuahua. I love volleyball, love food, traveling, and gardening. So that's just a little bit about me. Let's talk quickly about the agenda for today. As you have seen in some of the communication that has gone out regarding the ITCOP for this month and next month, in conversations with Marcy and Paul, we wanted to take an opportunity to talk to all of you about networking and infrastructure and give an opportunity to understand what it is that we do, what services we provide, and who are we? Who are the people that are behind these services that we provide to all of you? There's so much content to cover that we wanted to split it between the ITCOP meeting for November and the ITCOP meeting for December. Today is part one of that presentation. We'll be focusing on network design and capabilities. Part two of the presentation will be hosted on December 10th, and we'll be covering network operations. So I encourage you to attend the December presentation as well. I think you will find the content very interesting and very useful. Um, so back to the agenda. Today we'll be talking about networking and infrastructure, an introduction to what the actual group is all about. I'll talk briefly about that, and then we'll transition to Colin Baker, Director of Network Engineering, so that he can talk to you about the enterprise network, its design, its architecture, and its capabilities. That'll give you a good understanding of what the network looks like, um, uh, its architecture, and the design concepts that go into it to make it reliable, to make it performant, etc. Tim Worley, our Director of Enterprise Telephony, will talk about unified communications. He'll be covering things like voice over IP, analog telephony, contact center, and other features related to unified communications. And finally, Joe Clary with Special Projects will cover a little bit about cellular services so that you guys can understand how we support that particular technology on campus. All right. Well, let's go ahead and get started by looking at an organizational view of enterprise networking and infrastructure from the ITS perspective. As you all are aware, with the shared services model, uh, the organizational chart for ITS grew significantly, but this is where we fit in within that organization. Specifically, as it relates to networking and infrastructure, we have 6 groups that handle different areas of responsibilities for networking and infrastructure. And specifically, those groups have um, different areas of concentration, starting with infrastructure and operations, which is led by Dr. Eric Carroll. We have inside plant, outside plant that cover pretty much the needs of the university as it relates to structured cabling, fiber optic, copper cabling, and in other areas related to uh, infrastructure. There's also a component of geographic information systems under infrastructure operations that helps us keep track of the infrastructure, and not only the telecommunications infrastructure, but also utilities throughout the campus. In the area of enterprise telephony, which is led by Tim Worley, we have voice engineering uh, engineers that are responsible for supporting the unified communications network. And we have the cellular communications team, which is led by one person, Mr. John Lange. Um, Under project management, we have Jeff Banks leading that group, responsible for two groups, specifically one related to estimation that interacts with customers on looking at requirements for network connectivity and translating those into cost estimates. In addition to that, there's a group of project managers that take the projects that are funded and they manage the project from inception to completion. Under network engineering, we have Colin Baker leading that group with a group of engineers that help with network design and also an area of responsibility that deals with architectural review. Essentially, it's an area that looks at new construction and we ensure that the standards that we have established are followed. Under network operations, we have Klein Hendricks leading a team of engineers that are responsible for supporting the network. We have a network operations center, we have a wireless team, and we have a team of core engineers that support the infrastructure that provides services to the network. And finally, Joe Clary with special projects. He has responsibilities over the service management portion of our services and also has some involvement in cellular communications as it relates to negotiations with carriers and contracts. So that's the organizational view of networking and infrastructure. Again, let's just quickly talk about who is networking and infrastructure. NI is responsible for the design, installation, and the support of the enterprise network. The services that we provide include wired, wireless networking, wide area networking, network security, data center, cloud, telephony, and cellular solutions. And the services that we provide are for the benefit of the entire UK community, including the campus, healthcare, and all the members of the university. The reach of our services, and this is important to understand, go beyond the perimeter of the campus in Lexington. We have services that extend throughout the metro area in Lexington and beyond the metro area. These are just some examples of the facilities, the offices, the buildings where we provide and where we extend our services. From a statewide perspective, our services are extended all the way to the corners of Kentucky, east, west, north, and south. And again, these are some examples of the places where we're providing services to the entire UK community. Let's just talk quickly about infrastructure elements, local area networks, metropolitan area networks, wide area networks, and the internet backbone. And I'll hurry up because I don't want to take too much time. There's, like I said, a lot of content to cover. But if we zoom in into the infrastructure from a facility perspective, from a building perspective, you have horizontal cabling and backbone cabling that is required to create the physical infrastructure for the network. The cables, the copper cables, are aggregated into telecommunications rooms and eventually into an equipment room, which is also called an MDF or main distribution frame that eventually connects that infrastructure to the rest of the network. These are just examples of some of our closets and the equipment, the cabling, the electronics that are in them. If we zoom out of one building and we look at the campus, we see in orange some of the physical elements that enable the interconnectivity of the entire campus. So you have fiber optic cable throughout the entire campus, either through tunnels or through poles that are interconnecting all the buildings. And that again enables the connectivity among all the buildings on the campus. If we go outside of the main campus and then we look at the metro area, we look at Lexington, we leverage the infrastructure of our service providers to extend our services. We can do that through dark fiber services, which is physical fiber optic cabling. It's either dark fiber that rides underground or rides over utility poles, or we can use other technologies if dark fiber is not available. And again, as we go out of the metro area and we look at the entire state, we leverage, again, service provider technology to extend our services to all the corners of the state. We do that through a wide area network. Um, this is just an example of the infrastructure of one of our service providers. So just we're zooming out into the macro scale of the network. So service providers like this particular one, uh, we connect into their services, and then they take our traffic and eventually route it to the internet so that we can send and receive data. Um, Not only do we have services through commercial service providers, but we also have services through internet too to provide services to the research and education community. Um, and this is just an example of the map with the connectivity for this particular organization. Uh, the role of the network, just in closing, is just to support the university in all of its connectivity and communication needs. How do we make that happen? Well, we make it happen through careful planning, a robust infrastructure, secure architecture, and a comprehensive network management and monitoring. As Colin and Tim get into the specifics of the network, you will get an opportunity to see how we're able to accomplish some of these things. Last thing, the way that you accomplish these things is through also an amazing team. And we just happen to be very lucky to have a team that is very dedicated to support the network services for the university. The last slide, I promise, there are some challenges to maintaining the network and things that are within our control and outside of our control. It's, as I mentioned to you, the infrastructure, both on campus, the metro area, and the state, it just travels through a network of different things. It could be traveling through poles, through underground tunnels, through underground facilities, and it's all susceptible to various things like weather-related events, um, backhoes, which we love, even critters like squirrels that love to chew on cables, power outages, and you name it, the list is really, really long. So maintaining the network and the continuity of the network is a very, very big challenge for us, but that's why we have a large team with very capable people to support it. And that's it for me. Let me pass this to Colin Baker so that he can talk about network engineering.
All right. Good morning, everyone. Let's see how loud I can talk here. I think I hear it through the laptop, so we should be good here. As Hector said, I'm Colin Baker. I'm over our network engineering team. Trying to figure out how close I get. Okay, there we go. Hey, look, it's me. I am a Lexington native, so I was born and raised here. I went to high school at Dunbar. I've got about 20 years of experience in the IT industry overall. And I've been with UK for 2 different stints. I was here from 01 to 05 with auxiliary services, and I've been back since 2013. Famously, my hobby is collecting hobbies. So I'm currently on ham radio. So if anybody wants to talk about that, find me later. I think I got to get on the other side here. We're having trouble with the clicker. All right. So just org chart review here, where we're at again, as Hector mentioned. We're talking about the network and infrastructure team. Within network and infrastructure, my team is specifically enterprise network engineering team. From a org chart perspective, I've got 5 folks that work for me. Shelby Avery is a telecom engineer. Jackie Denault, Nick Rhodes, and Steve Napier are all network design engineers, and as is Mike Matone as well. He just recently joined my team from our operations side. So if anybody sees Klain, maybe give him a pat on the back. From an area of responsibility perspective, I have 3 main areas that I'm responsible for. We have Big C engineering and capital projects, wired network design, and wireless network design. Big C engineering and capital projects is Shelby's main area of responsibility. And he really has 2 things that he kind of focuses on this area, our standards and then capital projects, and as part of the estimation process. Within his standards operation, he's really responsible for everything that we do from an exterior and interior cabling perspective. So all of our copper and fiber cabling, both inside and outside. On the outside, things like service entrances to buildings for that copper and fiber optic cable, as well as manholes and duct banks. And then interior, like on the inside of buildings, he again is responsible for copper and fiber optic cabling path, and then communications closets and pathways. Within our capital projects process, this is going to be where he does like pre-estimate coordination and consultation with the capital projects teams, construction companies, general contractors, all of this. He's also responsible for planning, design, inspection, and testing, and then design review. From a wired network perspective, there we go. This is going to be Jackie and Steve's main area of responsibility. They are responsibility for producing designs on, as Hector mentioned, the LAN side, the MAN side, the WAN side, data center, and then security services like firewalls and security zones. And then Mike and Nick primarily are working in our wireless area. They're responsible for things like wireless controller design, access point placement, channel and RF profiles, and then coordination of authentication, authorization, accounting, AAA services for things like the wireless network through ICE. There are really four main methods of engagement for our team. We have the capital projects workflow, the estimates workflow, the ITSR workflow, and the incidents workflow. Capital projects are typically going to be things that are funded at the university level, and they are really a predecessor to the estimate workflow for capital projects themselves. What will happen is that Shelby will meet early on with the capital project team, as well as the construction companies, general contractors, and gather requirements to help influence what goes into the estimate process. He'll give them a budgetary number to hold for what ITS will ultimately produce in terms of an estimate. And then he also ensures that as they're designing the building, working with the architects, that they're following the appropriate ITS standards that Hector talked about, the MDFs, the IDFs, making sure that we have cabling run appropriately, making sure that we have the appropriate types of cabling, where it goes, all of these kinds of things. The estimate workflow is, as Hector mentioned, the way that the university community engages with ITS for sort of new buildings, projects, things of this nature. And this is the area where we do designs, both for infrastructure, wired, wireless. These are all input tasks to the estimate workflow. So our engineers coordinate with the project estimators that are on Scott's team under Jeff Banks. We produce those designs to meet the ITS standards that we have. And those designs typically include things like connection requirements, a bill of materials, and an idealized configuration for the actual network equipment. Sometimes we will get involved from a design perspective in the ITSR workflow. So typically this is going to be when things are much smaller in nature. They might be one-off. They typically will not have a large amount of things that have to be purchased with them. So we're not typically implementing switches in this manner, APs. And typically these are things that are sort of logical in nature. So if we need to make sort of a functional or logical change to the network, we might do it through the ITSR workflow. And then finally, we might get engaged via the incident workflow. So this is going to be in structure things that are similar to the ITS workflow, but are coming to us as kind of part of an outage or an incident-based thing. Again, often triggered by an incident or an outage. And these are often get looped into broader remediation-related estimates. So we might identify something via the estimate process that needs to be corrected, and then we might open like a large-scale estimate to address that network-wide or within a specific region or whatever. I wanted to talk sort of briefly about the actual structure of our network. So we have what we would call a 3-tier network. We typically have a dedicated core tier of the network. We have a distribution tier of the network, and we have an access tier within the network. Within the network, the core tier, kind of at the center of this diagram, is really the heart of the network. It's typically responsible for high-speed, low-latency interfaces. It only does layer 3 routing, so we don't have things like VLANs functioning at this tier of the network, and we don't span VLANs from one distribution block of the network through the other. There are some specific technical reasons we don't do that, but this right here is the main reason that we can't make VLANs from, say, the library available in, say, Memorial Coliseum. It's because we have this core tier of the network that doesn't operate at layer 2. It only operates at layer 3. The core tier is responsible for interconnecting those multiple distribution blocks, and then it's generally considered resilient, redundant, and geographically diverse. Specifically here on campus, our core tier is located within PKS2 and McVeigh Hall. The distribution tier is sort of the next tier down. It aggregates common geographic areas, and again is got high speed, low latency interfaces. This is the layer 2, layer 3 boundary in the network. So when we talk about things like a default gateway for a specific VLAN, this is where that default gateway lives, on the distribution tier of the network. The distribution tier is going to connect multiple buildings. So we might have somewhere like PKS2, which feeds multiple buildings in kind of the central area of campus. We might have another area like the library that's big enough to have its own dedicated distribution tier block. Again, the distribution tier is going to be considered resilient, redundant, and may have geographical diversity if we have to spread that across multiple buildings. Finally, we have the access tier of the network. This is sort of the ingress point to the network. This is where things like PCs are going to connect. It's also where things like laptops, tablets, phones are going to connect via the wireless APs. So the edge of the network, this is called the access edge, supports multiple connection mediums. Typically for us, it's part of the layer 2 network. So this is where our VLANs reside. It has different, within the access tier, you might have the access tier as part of the enterprise network, and then you might also have an access tier within the data center. So we have different need-based speed and latency offerings at the different access edges. So like in the data center, we may have capabilities that are different than the actual access edge out in a building. And then finally, this is going to be isolated to a geographic location. So it might be a specific floor, a specific area of a floor within a building, but it's going to be isolated. The network employs what we call service blocks. So these are self-contained functional blocks. They add functionality or extend the network into other domains. So this is the way, for example, that we get access to the internet, or that we have the data center, or that we connect to the wide area network that Hector mentioned. We have these different functional blocks. They're typically comprised of their own dedicated sort of pieces of core distribution and access tier technology. And again, they operate as a sort of functional block unto themselves. And then they connect to the rest of the block through the core tier and as a logical extension of the network. We employ something here called network virtualization. So we have a single physical network that spans throughout the entire campus and throughout healthcare. And what we do is through a construct known as a VRF, or a virtual routing and forwarding instance, we have the ability to create copies of that physical network. Those VRFs are isolated to themselves. And so when we create this copy of the network, or we create this VRF, it gives us a way to segment different types of traffic from a security perspective. So when you hear us talk about VRFs, VRFs are a layer 3 construct, and they are a virtualization of the physical network into a logical copy of that network. These are some of the GIS charts that Hector was showing before. I wanted to kind of pull this up and highlight just how big this network actually is, and we'll talk about some stats here in another slide towards the end. But again, we're seeing the fiber plant on the left, and then we're drilling down into the fiber plant on the right. Specifically, this is kind of the view of the area of campus that contains Cornerstone. So as you can see, we have plenty of manholes, we have plenty of ways to access the network, and we have fiber kind of running everywhere within the central campus area. I wanted to talk a little bit about internet connectivity. I think for the vast majority of the audience, this is going to be the thing that touches their lives the most. We are connected to 3 different networks from an autonomous system perspective. So our autonomous system is this bottom construct here on the bottom. We have a specific AS number 23162 that's associated with our network and represents us to the broader internet community. We then peer with 3 other networks. That's Windstream, the Kentucky Regional Optical Network, and TWC Spectrum. Within Windstream, there are 2 different VPNs or virtual private networks that we're connected to. They're broader Internet One commodity internet VPN, and then also KPIN. Internet One is a way to reach pretty much everything that's on the internet. So this is going to be just regular websites, things that aren't part of the research and education community, things that aren't cloud scale providers. KPIN is a VPN that holds some different state agencies. So COT is connected to KPIN. Some of the other state and higher eds are connected, and we can access those things just over the same physical links, but within a different routing domain. On the right-hand side, TWC Spectrum is another commodity Internet One provider. So again, here we have redundancy at this tier of the network within this service block. If our Windstream connectivity fails or our Spectrum connectivity fails, both of those things can back each other up. And then finally, we're connected to KYRON. This is a high-speed regional optical network within Kentucky that most of the higher ed institutions are connected to. And this network is the way in which we connect to Internet 2. We're going to talk a little bit more about Internet 2 specifically here in a second, but Internet 2 gives us access to two different VPNs, again, RPS and CPS. This is the research peering service and the commercial peering service. This is just two different route tables within the Internet 2 network. Internet 2 has got a lot of things connected to it, and again, we'll talk about those in a minute. Again, from a service block perspective, we have two dedicated appliances for the Internet Edge portion of our network. These are shown here, and again, they're located in PKS2 and McVeigh, so they're considered redundant, resilient, geographically diverse. And then finally, there's a pair of firewalls in between that Internet Edge tier of the network and the enterprise network. So there's kind of one way in and out of UK right now for most things, and that's to go through this set of firewalls and go to the Internet Edge. From a physical perspective, we have a 100G connection to Windstream, a 100G connection to Spectrum, and 200G connections to KYRON. And then from a logical bandwidth perspective, we've got 20 gigs on Windstream, 20 gigs on TWC and Spectrum, and we share 100 gig connections to Internet 2 with that entire KYRON community. This is the KYRON network. So it's got routers in this this top area here. Laser's dead. In the top area there in the blue box, we have a router for KYRON in Louisville. We have one here in Lexington at PKS2, and we have one at NKU. The KYRON network peers with Internet 2 directly, and this is how we get access to a number of different Internet 2 based services. University of Kentucky, Research Computing, KCTCS, Western Kentucky, Murray, Moorhead, Northern Kentucky, and Eastern are all connected to this network currently. This network is facilitated by Kentucky Wired. So there's a state initiative, Kentucky Wired KCNA, that provides infrastructure for the higher eds to connect, and then also for the regional optical network itself to be connected in Louisville, Lexington, and Northern Kentucky. KYRON is funded by the Kentucky Council on Post-Secondary Education. It's administered and supported by ITS. Again, it's a high-speed, low-latency network, and it provides access to things like state and higher education peers, and then the internet community, which includes a dedicated research network, RPS, a dedicated commercial network, CPS, and then other regional optical networks, higher educations, nation-state research networks, cloud providers, so things like AWS, GCP, Azure, DOE, other research and education utilities, and then other commercial customers who may want to offer services that are consumed by this community to this community in a high-speed, low-latency fashion. From an internet perspective, this is a graph of last week's bandwidth or utilization from the 6th to like the 10th. We're doing about 40 gig per second roughly at peak. And it's pretty sustained. So when students are here, we see that this number is much higher. When they go home for the summer, we see that these numbers are a little bit lower. But as you can see, we have utilization throughout the entire day. The purple line there is sort of a combined utilization, and then the others are dedicated lines on those individual services. I talked a little bit about the firewall. I want to show this community what it's doing for us. This is within 1 day last week that this is a threat overview of what that firewall is blocking. So anywhere from 5.6 million up to 31 or down to 31,000 threats, depending on severity. And then you can see here the action that we're taking on those threats. So informational threats we're sort of allowing. These are just going to be things like, hey, somebody might have scanned your network, all the way up to critical threats, which may have been an active attempt to compromise a website or a component or anything like this. And so this is the different levels of action that we're taking on these threats. But as you can see, we have a pretty large IP space and we're under threat constantly. This group in particular is probably familiar with our public IP project, by which we've been going through and securing firewall rules at the edge. And I wanted to show some of the results of that initiative over time. So what we see here is not necessarily threats, but this is blocked traffic for unsolicited inbound requests. So for a host that may be directly accessible to the internet, we get inbound traffic, and we get that in an unsolicited fashion, meaning it was not a response to something that was initiated from a connection inside the network. It was an attempt to come from outside the network to inside the network. And as you can see, we're blocking a number of those threats every hour. I think this is an hourly, like these individual lines are hourly lines, and it can be anywhere from 20 million up to 40 million blocks per hour that are a direct result of that public IP project that we've been doing and our desire to block things at the edge. And that's why it's so important. So just to give a quick overview, again, it's a statewide network. We've got more than 3,300 network devices and more than 11,000 APs. We've got like almost 1,160 communication areas across 270 buildings, 885 different cable pathways, which is almost 30 miles. Some of those are aerial, some of those are underground, and some of those are in the tunnels. We have more than 2,200 individual fiber cables, and a fiber cable can be made up of anywhere from 12.6 to 288 strands. So we have 575 different outside plant cables. In terms of strands, that's almost 6,600 miles of outside plant strands. Inside plant, we have about 1,700 cables, and that's about 1,144 miles in terms of individual strand count there. And with that, unless there are any questions, I think Marcy was monitoring questions. We'll turn it over to Tim.
I've been a resident of Kentucky for over 35 years. I was a hospital corpsman in the Navy. Specifically, I was a combat medic with the Fleet Marine Force in Camp Lejeune, North Carolina. After that, I got out and I went into IT immediately. I've been doing that for almost 25 years. 18 of those have been with UK. I had to scratch out basketball and put golf there. I got too old to play basketball, and it turns out they let you play golf when you're terrible at it. So I also enjoy hiking and 80s metal. This is a quick overview, again, of the organization chart. I think we'll drill down. I'm under the same group that Collins Group is under Hector, and I with Enterprise Telephony. My team specifically is comprised of Sean Roddy, John Lange, Gafour Tagizadeh, Tom Morton, Mike Tabin, Josh Holbrook, Jacob Maricini, Mark Beatty, and Ann Stevens. These engineers represent over 165 years of combined service to the university. That's about 16 and a half years per engineer. And I have to admit that Ann Stevens bumps our number up a little bit. She's worked at this university since 1979. That's 45 years, folks. Mind blowing. Some of the things that we are responsible for: the UK call routing and dial plan administration, obviously Cisco VoIP phones, analog telephony, IP paging. We also manage contact center. UCCX is the legacy. Five9 is the new contact center as a service that we just procured this year. I'll talk more about these systems as we go. We also manage cellular and distributed antenna systems. And as Hector mentioned earlier, we have a dedicated cellular engineer, John Lange. We also manage some of the 911 and emergency notification systems. And that includes routine notification systems as well. And we have many other interconnected systems that flow through the voice network that include Things like Volt in the hospital, Vocera, WriteFax, Fax over IP, and a bunch of other things. I have a small team, but I wanted to kind of show kind of the work they do. In the last 12 months, they've closed over 4,000 tickets, IT service requests, incidents, and this is in addition to project work and just general maintenance of the voice network. They're a very small team and they're very busy. Don't get an opportunity to brag on them as much as I would like to, and I just want to point out the work that they do for this university. Some of the things that they do is just not just voice, it's just not telephony. They're a very well-rounded group. They have to touch a lot of things. They get involved in a lot of things, contact center, voicemail, configurations of devices. They deal with fax issues and analog issues, desktop support because there's many soft phones at UK, headset issues, voicemail boxes, all kinds of things. They are involved in many things and have to be well-rounded and know a lot about the things that occur on the network at UK. I wanted to add this slide just as a talk a little bit about the evolution of telephony at UK, at least since I've been here. This picture here is an actual picture of the Lucent 5ESS switch that exists in the basement of Parking Structure 2 today. This was the original analog switch. This is an enterprise class carrier grade switch that used to be the main phone switch for the university. This had at one time 20,000 lines on it. Obviously, VoIP has taken over in the last several years, and we're trying very hard to sunset this piece of equipment. It takes up 2,000 square foot in the basement. Butch Atkins would love for me to get rid of this thing. I'm working on it, Butch. Today we have less than 800 lines left on that. So we're on track to get rid of that very soon. As you guys in IT probably know, the last 10% of these projects are very difficult. So we're working on it, but we'll get it done. One day we'll see this thing winched out of the basement, and it is a gigantic piece of equipment. Quickly, basic representation at the heart of collaboration at UK. Everything that we do, the engine that runs that is Cisco Collaboration. I'll talk a little bit more about this, but everything that runs, all the communications that we handle are like telephony, contact center, talkaphones, emergency blue phones that you see on campus, even Teams and other systems like Volt, and of course, we have a connectivity to the public switch telephone network. In our case, our main carrier is Windstream. This is just a kind of a simple representation. This next slide, I believe, shows a more technical drawing. And that very center section there, those are 5 virtual machines that basically are responsible for all the call routing and processing for every leaf system at Kentucky, at the university, and for all the internal systems and connectivity to the PSTN. The main system that we use is Cisco Unified Communications Manager. It provides the centralized call control and management for voice and video messaging and mobility services at the university. It can support up to 80,000 users per cluster and allows clustering for scalability. It has features like unified mobility, which we call here single number reach. It enables users to stay connected to their work number from any device. It's a highly available and geographically redundant system. We have assets in Parking Structure number 2, Pavilion A, and Martin Luther King Colo. Everything we do is based in open standard SIP. So we have a call processing system that we call Session Manager, and that is the SIP hub, and it facilitates all the trunking between all the leaf systems that we have at UK. So all the call processing happens through SME. Specific to us, we have 4 separate clusters of CUCM. As I mentioned, it's geographically redundant in PKS2, MLK Colo, and we even have some pieces in Pavilion A. It's comprised of 26 physical servers and VxRail hyperconverged infrastructure. We have 60 virtual machines that make up voice infrastructure here. We have about 17,000 devices connected to that. It includes Cisco VoIP phones. We use Cisco voice gateways to provide some analog dial tone for some legacy stuff like fax machines, modems, other things that require alarm systems, elevators. We also integrate with Teams, and today we have about 4,100 Teams only telephony users. They only use Teams for their phone. We have 40,000 DIDs at UK, and we own 4 full 10,000 blocks of DIDs. So we have a lot of phone numbers and a lot of inventory to manage here. Cisco Unified Contact Center Express. We've had this is our legacy contact center. We've had this for 20 something years. We're trying to sunset this, but some information about that is basically it handles customer interactions across multiple channels, voice, email, chat, and social media. It routes customer inquiries to agents for, service desk uses it. Many departments in healthcare use this for agent-based communications. It's IVR, interactive voice response system, to automate customer interactions and guide them to the right resources or agents. It includes real-time and historical reporting capabilities. And agents use what's called the Cisco Finesse desktop, which is just a web-based agent and a supervisor desktop that provides an interface for agents to use for answering calls at UK. We've had that since 2012. As I mentioned, we're trying to sunset this. It's comprised of 4 separate VM clusters today. We have over 100 tenants, and tenants for our purposes means departments. This includes the IT service desk, both for healthcare and for campus, all the pharmacies, most of the UK healthcare ambulatory clinics, parking uses this, athletics, human resources, many departments at UK use contact center. Back in December, today we have over 1,000 call center agents at UK that use contact center. Back in December, we awarded a contract for Five9. This is going to be the new contact center that's going to replace UCCX. We're currently rolling that out. It is basically does the same thing that UCCX, as a much more modern and robust feature set, and it does, allows the same thing to same channels: voice, email, chat, SMS, and other social media channels. IVAs, there are some AI-powered virtual agents to, just to reduce the number of actual human interaction and make things much more efficient for customers that call the university. It is cloud-based, nothing on-prem in this, and for this system. Same thing, it does provide real-time and historical analysis. Smart dialer, so we can do predictive outbound dialing for campaigns and scheduling and things like that. And it integrates with our CRMs, and we are integrating that today with Salesforce, Epic, and ServiceNow. It is the new contact center platform, as I mentioned. We awarded that bid last December. All cloud-based service, web-based agent soft phones. Phase 1 is complete. Both service desks at UK are on this, and I think we have one smaller patient access center that's out at Alumni that is already rolled out to this. Phase 2 is underway. It's going to include the conversion of the pharmacy and the patient access center. And then phase 3 and 4 will include the remainder of the tenants at UK. As I said, UCCX will be retired as the agent-based contact center platform. Unity Connection, that's our voicemail platform that we have at UK. It provides, advanced voicemail functionality, customized greetings, message storage, retrieval options, and many of you have used this and continue to use this service today. It integrates with your voicemail. Most of it, I get my voicemail in my email. Most of you probably do as well. So that integration exists today. There's a web component as well. If you want to log in, we have a URL. You can log in and visually retrieve your voicemail and listen to, play and manage your voicemail from the web. And it is HA and highly available in disaster recovery. Has redundancy and failover capabilities. It's 2 dual node virtualized geo-redundant clusters. Today we have almost 13,000 mailboxes on Unity. And that represents 85 gigs of stored data, which is about 330,000 voice messages. Clean out your voicemail. Informacast Fusion, this is the IP paging and mass notification system that we use at UK for IP telephony. It sends alerts to phones and a bunch of other devices, including the Blue Talkaphones, IP overhead IP speakers, desktops, mobile devices, a whole bunch of other things, digital signage even. We've used this for many years. You can do pre-recorded emergency or you can do ad hoc broadcasting with Informacast. And it uses multicast to route those messages over the network. That is 10 VMs comprised of 10 virtual machines today. It sends alerts to over 50 emergency Blue Towers all over campus. We continue to add those. I think we just added 4 more this week. 200 IP speakers. Mostly these are used in healthcare for emergency notifications, code paging, just general announcements in a lot of clinics, particularly in Pavilion A. We can broadcast to all the voice over IP phones if we wish. UKPD also integrates to this system with their Rave emergency notification system, and they often send alerts via Rave to Informacast. And we get about 2,000 broadcasts on this system a week. Cisco Emergency Responder, that is what we use for Enhanced 911 here. It tracks the location of IP phones and provides location data to the PSAP. UKPD is its own PSAP. We have our own dispatch system here. We have our own E911 system at the university. Real-time location tracking, so it monitors the physical location of any phones as they move within the network. Back in the analog days, you couldn't do that, but with IP, we are able to do that. PSAP call routing, and ensures emergency calls are routed to the correct PSAP, which in our case is UKPD. We have over 700 ERLs, emergency response locations, and that ERL represents a building location, and in some cases in larger buildings, it references the floor of the building. We track phones across about 1,600 access switches. So as the phones move around, people at UK have just picked their phone up and take it with them to, if they move departments or offices or whatever, they usually just pick their phone up and take it with them. Cisco Emergency Responder will track that move. We also have, as I mentioned, an E911 system, and that is called the Motorola Vesta system, and that is housed in parking structure number 2 and at the Windstream Colo downtown. A couple quick metrics about voice here. This is just the number of calls per month that we do. We do over 2 million calls a month, probably. Obviously in 2020, something very significant happened. That was COVID, obviously. So that average is a little bit skewed here for this 6-year average, but on average, we probably do around 28 million calls a year inbound and outbound at UK. Long distance, we average around 350,000 calls a month in long distance at UK. And the last thing is just an interesting metric I thought, people would be interested in, is the average call duration for all calls tracked across UK. And we're somewhere around, an average call is around 2 minutes at UK. And that's been consistent for as long as I can remember. So that's, for the amount of calls I think that we do, that's a pretty good sample size. Yep, I think that's it for me. Joe Clary's going to talk a little bit about the cellular and DAS systems here.
Well, good morning. I appreciate everybody's time today. A lot of good information Colin and Hector, of course, and Tim gave out. Cellular DAS systems, if you could advance the slide when we see them, I'd appreciate it. Okay, just a little bit about me. I grew up in South Carolina. I joined the Army, was in Army Aviation and Communications for a few years, and then I was employed by cellular carriers right after. I've been with UK since 2008, and my hobbies, really, I've got grandchildren. Who has time for hobbies at this point? If you could advance. I kind of work with special projects inside Hector's organization, and there it is, right inside Hector's organization. So why do we do something with cellular service as far as ITS is concerned? As you know, UK is not authorized or licensed to provide cellular service. The main carriers, AT&T, Verizon, T-Mobile, have spent millions actually billions of dollars buying licenses and getting themselves capable and licensed to do that. So we can't do that. But why is it important to us? It's important to us because our customers use this service. Our students, our patients, our faculty and staff, our clinicians, they use it on a daily basis. I looked at some statistics that were kind of interesting to me. 97% of Americans own a mobile phone. 90% of them own a smartphone. And I've got to believe in this group that we're talking to right today, that 90% is probably a very low figure. I would imagine probably close to 100% of the people that are listening to this have a smartphone. An interesting thing, another interesting statistic is on average, Americans spend 5.5 hours daily on their phone. They look at their phone 144 times a day, and if you consider that we sleep at least 5 hours, that's 7.5, every 7.5 to every 8 minutes, people look at their phones. Over half the world's internet traffic comes from mobile phones. So it's important to our customers, and it's important to the university. So how do we provide cellular service? If you look on the left, there is that's a macro cell site, and it's a picture of a part of macro cell site on top of W.T. Young Library. In the middle, you've got a small cell. That small cell is located between Singletary Center and Gatton Student Center. A macro cell site is what you typically think of as a cell site when you're driving down the road and you see a tower on the side of the road. It's got a lot of antennas, and it covers traffic, mobile traffic, voice, walk-in traffic, and it covers our macro cells, both on campus and surrounding campus, cover most of the exterior areas. The small cells cover a more focused area. They can provide some additional capacity. They can provide additional coverage if needed be. And both of those are managed, maintained, and owned by the cellular carriers. So there's very little that we can do to influence that other than through some negotiation. What we do have a little bit of control over is our DAS. On the right-hand side, the right picture is a single antenna for our DAS system. This one happens to be in the Student Center. And those are owned and maintained by UK ITS. One interesting thing about it is a DAS will do nothing for you if you can't feed a signal into it. So we still have to take signal from the cellular carriers, put it in our DAS in kind of a head end, pipe it out to the remotes and then to the antennas. And all that has to happen in every building that we have a DAS in. So if you could go to the next slide, you can see we have about 27 buildings right now where we've got DAS or repeaters located around campus. And that number is growing regularly. So what do we do as far as cellular service here? We interact with the cellular carriers so that we negotiate, make sure they're properly following their lease, try to get new leases. We try to work with them to increase their service to the university, 5G services and things like that, deploying those small cells across campus. We work with other departments across campus so that we can get the power to the poles or to the small cells and to the fiber. So we work with many organizations across campus. We also, if someone wants to put in a request for an estimate to get new DAS installed in a building, certainly John Lange will work with our vendors. John Lange is the cellular engineer. He will work with the vendors to come up and help the estimators produce the estimate for the customers to fund. And if funded, John Lange will typically do the installation across campus for the DAS systems. And he's responsible then also for all the campus and healthcare DAS maintenance. Just to give you an idea, though, a DAS system, depending on whether you need just a very small area in a building or the entire building, can cost in the tens of thousands up to over $1 million for a building. So it's not a small investment when you decide to make it. I just wanted to let that out there. And the next slide, and I think that's all I've got.
If there are any questions that you want to follow up on, any ideas, any complaints, or whatever, feel free to send us an email. Feel free to call us, and we'll be more than happy to talk to you and go over some of the details of the information that we provided to you today. Like I said, it's just a lot of information that we covered today, and this is just covering the surface of the services that we support. So again, I'm sure some of you will have questions, so just feel free to reach out to us, and we'll be more than happy to answer your questions. For the presentation on December, again, I encourage you to attend. We'll be talking about how you request services from us. We'll be talking about operations and some other aspects of the work that we do. And so we put together the content just to make you aware of these things. So I encourage you to attend. I would encourage you to come to Coldstream and meet us in person. We decided to follow, I'm sorry, Cornerstone. No, don't go to Coldstream. Sorry. We decided to follow this format again to give you and to give all of us an opportunity to meet you in person. I think it's important to continue to create those opportunities. So if you have an opportunity to come see us, shake our hands, talk to us, please do so. We'll be very excited to see you.